this piecewise function has 3 different parts to it, and we're still going to use that same process even though we've added another part. And so that process is extendable for however big your piecewise function is. As always, we're going to start with the domain and work on putting in those fence lines. So we see that we have a break at x equals -2 where we switch from one function to the other. So I'm going to put a fence line in here. Okay, and then we have another fence line here at x equals 3. So let's get that one in. Okay, and now we've dealt with our domain. And let's look at the functions that are going to control the graph in each piece. So for x less than or equal to -2, I have y is equal to -4. For x between -2 and 3, I have y is equal to x minus 2. And then for x bigger than 3, I have y is equal to -2x plus 4. Okay, so those would be the functions that fit in each one of these sections. I'm going to start with the middle one since it's in slope-intercept form, and that includes my axis. This should be easy to plot. So my y-intercept is -2. My slope is +1. There's that imaginary or invisible 1 in front of that x. So I just go up 1 over 1. And when I hit the fence line, I'm going to put in a hollow dot there. And then once I do hit the other fence line, I'll do the same. I'm going to connect those 2 hollow dots, and then we'll come back and decide which, if any of the dots need to be filled in. All right, that gives me my center section. Let's look at the section on the right. So this says y is equal to -2x plus 4. So I know I have a y-intercept of 4, which should be up here, but it's not in the right section, right? This graph needs to be over on this side. So I'm going to use a pencil just to kind of lightly mark in until I get over across the fence line. So the slope is -2, so down 2 over 1, down 2 over 1, down 2 over 1. So this is where I can pick up my function. So I'll put a hollow dot there, down 2 over 1. And then I'll just draw this line in and we'll put an arrow on it since it keeps going. And then this left-hand side, we have y is equal to -4. That's just a horizontal line at -4, which is right here. And so we can draw that in like this. All right, so that gives us the basics of our function. Let's decide if we need to color in any dots. So this first function, there is an equal to, a less than or equal to here. So we would color in the dot that's associated with this. And that would be this dot right here. The middle function, there are no equal signs on either one of those. So we would not color in either dot related to those. And then there's also no equal sign on this one. So that means neither of these dots at x equals 3 are going to get colored in. And what that's going to do is that's going to affect our domain because we don't have a value here. So let's identify what our domain is. So the domain is all the x values, and we see that they start all the way out at x is -infinity. And they keep going. We have values. I can follow my function until I get to x is -3. There's no value here. So I need to stop my domain here, and I can do that with a rounded parentheses. It says go up to every number close to 3, but not including 3. And then it does pick up again just after 3, and the x values keep going out. So I have -infinity to 3 and 3 to infinity. And then for the range, so we're looking at the y values. My lowest y value is going to be -infinity, where this arrow is. Okay, and I see it comes up. We hit some values here. There's a hollow dot here, but there's a filled in one here. So that takes care of this. It looks like our highest y value is just shy of 1. So I'll put a 1 here with a rounded parentheses, and that gives me my range. All right, let's go through and find some of these values that are listed here. Let's start with f of -4. So f of -4 is going to be located over in this section here. And it doesn't matter what your x value is there, your y value is -4. So that's a nice, easy one to fill out. X is 1. So x is 1 is here, and it's in this middle section. So I could use the graph to do this, or I could say this is the function that I use when x is equal to 1. And so this would be 1 minus 2, which gives me a -1 here. right, f of 5. So 5 is going to be right over here. That's in this section with the negative 2x plus 4. So I'll plug that in, negative 2 times 5 plus 4. So that's negative 10 plus 4. That gives me a negative 6. Right, f of negative 2. So this is on the fence line. These are the ones you have to pay close attention to. Graphically, there's just the 1 point here, so that does make it easy. The other way, if I'm just looking at this part of the piecewise function, I see that the negative 2 is included in this first part. So I get that value of negative 4 there. Right. F of 3. So f of 3, I don't have any colored in dots. I don't have an equal sign on that 3. F of 3 doesn't exist. It is undefined or does not exist. Either one would be totally fine. All right, so there is example 3.